All right, kiddos, we are going to expand past the absolute value, and we're going to move into families of functions. And all that means is we can change the picture of what's going to happen here as far as the parent graph. So you see that first we're going to deal with just a linear equation. So this one has a slope of 1, a y-intercept of 0. So we're talking about this graph to get started. Now the only difference is, check out our second one, still a slope of 1, but it starts down here, up 1 over 1. Okay, so they'd be parallel lines. So what we talked about in the last section with absolute value is having -2, right, outside the parentheses, outside the absolute value. That's going to start to move that graph either up or down. In this case, it moves it down. But the other thing we want to start to relate is what's going on with the ordered pairs. So if we plug in x, we get -1, 0, 1, 2, 3. Now if we plug -1 in here, we get -3. If we plug in 0, we get -2. Plug in 1, we get -1. Plug in 2, we get 0. And if we plug in 3, we get 1, right? Because it's 3 minus 2, 2 minus 2, 1 minus 2. Okay, so these numbers aren't completely random. Right? We're plugging them in. So what we want to start to understand is that's changing the range, right? The y values are changing -2 from what we had because we had a vertical translation down 2. So all these numbers are now down 2 of what they were. So we shouldn't have to use a full table. If we give you part of the table and ask you to make an adjustment, we can start to make that happen as well. Just as easily as you did by moving the graph down 2, we can also come back and move all the data points down 2. Okay, so how's that changed just a little bit? Well, what if I start where it's already -1? So I get -1, and then what happens is we start getting our graph. So I plug in -1, we're going to get 0, right? That's the vertex, that's where we started. If I plug in 0, I get -1. And if I plug in 1, right, so now I have 1 squared minus 1, so I get 0. And if I plug in 2, right, 2 squared minus 1, so we're at 4. Minus 1 gives me 3. Okay, so 2 gives me 3. And I would also have -2 gives me 3 for its reflection. So this is our original function. What happens if we translate it up 5 units? Okay, so that means I would take each of these ordered pairs. I would go 1, 2, 3, 4, 5. Here's my 5, here's my 5. So we get exactly the same thing. So that means the vertex point, instead of being at -1, is now at 4. Okay, so we're going to add 5 to each of these. Okay, so I want to make sure still we're trying to illustrate this with the graph. We want to try and wean ourselves off the graph so we understand that we could just change all these values. If we had the original table, which I have here in green, then we can go ahead and change those range values as well. All right, so the graph shows the projected altitude for an airplane scheduled to depart an airport at noon. If the plane leaves 2 hours late, what function represents this transformation? Okay, so here's what we have going on. We have f of x. It is whatever this weird looking shape is for the altitude. Now, would this turn into the function +2? Okay, so has it been moved up 2 based on all the things we talked about? No, right? So this would be the function. And if we want to move to the right 2, we're going to put 2 on the inside, but to get to the right, we're going to go with minus. Okay, so we're going to take all those ideas. So this would be just like the absolute value. And if we wanted to move it to the right 2, we'd put it inside. So using that inside was very specific all this time. That's how we're going to move things left and right. If we put things on the outside in function notation, that's going to move it up or down if we make it minus. All right, let g of x be the reflection of f of x, which is 3x plus 3 in the y-axis. What's the function rule for g of x? All right, well, we didn't talk too much about the y-axis reflection. Well, what that means is we're actually going to plug negative into the function. So that means we want negative x. So we want 3 times negative x plus 3. So this result is supposed to be what's now called g of x. So this would be negative 3x plus 3 would give us g of x. Okay, since that was a y-axis, I understand that one might be a little bit confusing. Okay, but we'll make sure we put it in, because if we want a x-axis reflection, okay, that means we're going to use negative of the function. Okay, so that means we want to flip the whole thing. So that means we need negative times 3x plus 3, because we want negative f of x as a result. So negative 3x minus 3 gives us h of x. Okay, so our reflection, remember the a value? So if it were negative 2x plus 1, close that up for the absolute value. And this negative 2 means we're going to flip the whole thing over. So this function has been flipped over completely about the x-axis. All right, so the table below. So here, we're not going to give you the graph this time. What's the corresponding values of g of x and possible graphs of g of x for the transformation? Right, so we're going to take f of x. What are they telling us to do with it to make g of x? So we're going to make one more column here and say that these are the results for g of x. How do we get g of x? I multiply f of x by 3. So that means 2 gives me 6. 2 gives me 6 again. Negative 3, right, gives me negative 9. 1 gives me 3. And negative 2 gives me negative 6. What in the world could that graph be? So let's take a look at it. So negative 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Negative 2 is also at 6. 0 is at negative 3. And 5 is at negative 6. All right. So what we've done is we've stretched all the points out. Okay, so we do have kind of a horizontal piece here, which means we're talking about some sort of function we haven't really dealt with just yet in Algebra 2. So possible graph. Okay, so this is our possible graph. Something could be happening in here that we haven't covered overall in Algebra 2, but we have all the x values and corresponding y values, and that's what they look like. All right, so we'll just deal with getting this extra column here. I don't know if this graph would look any better than the other one or not. So what happens? And so I want to get h of x. So we're creating this new function. How do I get it? I have to multiply f of x by 1/3. And so I have 1/3 times 2. Well, that's 2/3. This is another 2/3. I have 1/3 of negative 3. That's just negative 1. I have 1/3 times 1, which is 1/3. And here we're going to plug in negative 2 times 1/3 to get negative 2/3. Okay, so we've taken all these points and we've shrunk them down, right? That's why we call this a vertical compression of 1/3 in this case, because all the points, instead of being much taller, are going to be a lot shorter. All right, combining these transformations. So we have a quadratic. We're going to start with f of x. Okay, they're saying what transformations have to happen. So how can I get 2x squared to turn into 6x squared? So the first thing is we need a vertical stretch of, right, well, 2 times what gives me 6? 3. And then after we've done that, so the order matters here as well. After we've done that, I now want to subtract 1, which means what? We want to take the function and move it down 1 unit. Okay, so that was that minus 1. All right, the graph of g of x is just plain old x here. So what do we have to do to make g of x? Well, what did they say? Stretch vertically by a factor of 2. Is it plus 2 or multiply by 2? Yeah, you know by now. That's multiplied by 2. And then translated down 3 units. Okay, so the new g of x, so we started with plain old f of x equals x. We have it vertically stretched by 2 and translated down 2 units. All right, so horizontal and vertical, this should look extremely familiar. If we want to move it up, right, this is the absolute value of x plus k. This is the absolute value of x minus k. We're just making this for any function. This is the absolute value of x plus h on the inside. This is x minus h on the inside. So that's how we're going to move them up, down, left, and right. Using our function notation, we can show exactly the same thing, that whatever we're doing, whether we put it inside or outside, makes it move left and right versus up and down. All right, what we did up above, so this is kind of the same thing. This one's, I think, is a little bit harder for students. So we're really focusing this on our hybrid days when we're together. X-axis means we're going to multiply the function by a negative. A y-axis reflection, again, not overly common at this point in Algebra 2. That means you're going to replace x with negative x in the function. The last two, you should be super familiar with, right? If we multiply it by a, if a is greater than 1, that's that vertical stretch, right? Those are called VS. If it's a less than 1, it's a vertical compression. Okay? Now we mean that it's going to be a decimal or fraction. Okay, so if it's a fraction, it's going to be a proper fraction so that it falls in there. Well, what happened if it was negative? Well, if it was negative, then it went back to here to be a reflection. All right, so we're going to describe the transformations. So I'm going to deal with a couple of these. So I'm going to go from f of x and then turn it into g of x. Well, they have one single number, -5, but that actually means two things, right? It means an x-axis reflection, and it also is multiplied by 5. So is that a vertical stretch or vertical compression? Well, it should get taller, so it's a stretch. Even though it's upside down, it's taller. All right, number 8, we're going to start with 1. First thing is it needs to multiply by 1/4. Okay, so what happens there? It's a vertical compression of 1/4. It's going to make it squished, and the +3 now means that it's going to be moved up 3 units. All right, I think in lieu of graphing here, if you can describe it, I think we'll be in good shape. So we're going to take 2x, so it's already been stretched, but that part is going to stay put. So we're going to take that and we're going to move it down 2 units. And if it's multiplied by negative on the outside, that's going to be an x-axis reflection. So we're going to take x squared, right, or quadratic. We're going to move it down 3. But we're also going to give it a vertical stretch of 2. All right, so not too shabby. So those are the things we're going to deal with. We're going to test your knowledge, see how well you understand it, and hopefully give some clarification in class.